Hello student. Today we are going to do logarithmic differentiation. So before doing the differentiation, first we have to know when we are going to use logarithmic differentiation. That means when this type of differentiation is done. You see, if the power of a function is a variable, okay, power means exponent. Exponent is a variable. In that particular case, we are going to use logarithmic differentiation. That is, we take log on both sides and then we are going to do differentiation on both sides. Okay, or sometime you see when the number is a product of a large number or product or division is combinedly written. In that particular case also we are going to use logarithmic differentiation. That much you have to remember. So here I have written, in this section we will mainly discuss derivatives of the function of the form fx to the power gx. You see, here I have written the power is a variable. Okay, power of the function fx is a variable where fx and gx are functions of x. Okay, when the variable occurs in the exponent, in that case what I am going to do, we are going to consider it as a function, say y is equal to fx to the power gx. We have to name the function as y, or another variable also you may use. And then what you have to do, you have to take log on both sides so that this function can be simplified. So if you take log on both sides, that is, here I have written by taking logarithm to the base e. Here actually we understand when we write down log, that means nothing is written, means we know earlier, that is, the base is considered as e. Logarithm of both sides, we get what? Log of y is equal to log of fx to the power gx. And we know by the property of logarithm is what? When the power is given, then it is written as a product. That means gx will come as a product, g of x into log of x. Right? Now you see, here your function is converted to product of two functions. Now if I go to, after getting this is simplified, and after this we are going to differentiate both sides with respect to our variable, and in this case our independent variable is x. So we differentiate both sides with respect to x. That means we are going to take what? ddx of log y and ddx of gx into fx. Here I can do it differentiate, and on the side what is the formula we are going to use? Product rule, because this is a function of x and this is also a function of x. So you have to use here product rule. And here if I think y as x, then ddx of log x formula can be used. That means we are going to use here chain rule. Then what is the value of ddx of log y? It will be equal to 1 by y. And as we are thinking y as x, so take derivative of y with respect to x. On the right side we can use product rule, as I told you just some time before. So product rule is what? U ddx of the second function plus second function ddx of the first function. Here the first function is gx and the second function is fx. That is u ddx of v plus p ddx of u. Just this formula I have applied. Always you try to remember your formulas. Okay, everywhere they will be used. Now after this step I had tell. Okay, 1 by y, and this is dy dx. It is simplified already. Gx, keep it as it is. What is the value of ddx of log x? Log of fx. Fx you have to now think it as x. It takes the form log x form. And ddx of log x equal to 1 by x. So it will be 1 by fx. And you have considered fx as x. So take derivative of fx with respect to x. Log of fx, you can keep it as it is. And derivative of gx can be written symbolically as z dash x. Just the notation, we know it earlier. So this is equal to dy dx equal to y. I just bring to the right side because we cannot write the answer in terms of y, as y is considered by you only. It's not given in your question. So write down it is y into the right side. That is what? Gx by fx, z dx of fx can be written as f dash x log x into z dash x. Now you replace what is your y in terms of the given function. So what is your y? You have replaced here, this is your y, fx to the power gx. So replace this y by fx to the power gx. Then we get fx to the power gx, gx by fx, f dash x, z dash x, and log of fx. Conventionally, we write down this as the first term and this as the second term. First product of the, that means the factors. This is the first factor and this is the second factor. In this method, fx must be positive. You try to remember it. Fx must be positive because negative of logarithm we cannot define. And this method, this process of differentiation is known as logarithmic differentiation. Hope you understand logarithmic differentiation. What is logarithmic differentiation? That means we have got when the power is a variable, we take log on both sides, and after doing log, the next step you have to simplify. After simplification, take derivative, that is ddx on both sides, and then you use formula of derivative. And lastly, you write down what is your answer. Okay. This method is also used to differentiate a product of number of functions or a quotient of a number of functions. Just some time before I had told you these things. That means in case of large number of product, when many more terms are given, more than 3-4 terms are given, then we are going to use this differentiation, that is logarithmic differentiation. After this, we have to know our result, which we have got. We know the result, but I had not given you the proof. Okay, so now I am going to give the proof of this result. Differentiate a to the power x with respect to x, where a is a positive constant. So a to the power x, you have to take differentiation of a to the power x. Power is a variable. So we think it as y. Let y is equal, we name the function as y. Y is equal to a to the power x. Take log on both sides. So log of y equal to log of a to the power x. Log of y, don't have to simplify anything else here. Just keep it as it is. And this is what? Log of a to the power x. Power is there. So powers can be written as a product. So it becomes x log of a. Right? And after this, simplification step is done. After this, we have to take ddx on both sides. So ddx of log y is equal to ddx of x log a. Is not it? So why you think it, the next step ddx you have to do. Why you think it as x, then log x formula. Log x formula is 1 by x. So it will be 1 by y into dy dx. Log a is constant. It will come out of the derivative and ddx of x is equal to 1. So what we have got? Dy dx equal to y you being to the right side, because as I told you earlier that y you cannot write the answer in terms of y. Okay, so y you bring to the right side into log of a is there, and ultimately change this y. What is your y? Y is a to the power x. So the value of ddx of a to the power x is what? A to the power x into log of a. This is the formula you try to remember. Okay, now I give you some examples. After that I will proceed to exercise of our textbook. Okay. So, I just give you the first example. Differentiate under root x minus 3, x square plus 4, 3x square plus 4x plus 5 with respect to x. This is a large function. You can think it as x and you can do the derivative. That is, ddx of root x formula can be used. If you use the dx of root x formula, then root x again you have to derivative, take derivative. That is, the dx of u by v rule will be applied. Again with u by v rule, again the product of function is there, that means u into v rule, again you have to, so you think it's a very large number. That's why if I take logarithm on both sides, then exponent will come as a product, and after that multiplication and division will convert to what? Sum and the difference. Right? So I just name it as y, let y is equal to this expression, then take log on both sides. Log of y is equal to log of this expression. But root over we know can be written as a half, product power is a half. So I have written as a power because we know logarithm of power can be written as a product. So what we'll get? The log of y is equal to this power. Power will come as a product. Log of this division term. And log of division can be written as log of m by n formula. What is log of m by n? Log m minus log n. Division will convert to difference. So log of the above expression minus log of the denominator. After that, half you keep it as it is. This is the product function. So product, log of m into n, that is product will convert to sum. Log of m into n can be written as log m plus log n minus log of this expression. You see now this is convert to a simple linear expression. Simple expression. There is no division terms is present here. So now after simplification, we are going to take ddx on both sides. So ddx of log y is equal to ddx of the whole expression. And when you take the ddx of this whole expression, half is a constant, so it will come out of the derivative. Then ddx of this plus ddx of this minus ddx of this can be written. So I have written ddx of log of x minus 3 plus is there. ddx of this one, u plus v and u minus v rule I have applied. ddx of this expression minus is there, ddx of this expression. Now, what is the derivative of log of y? Think is y as x and become log of x formula. Log of x is 1 by x, so it will be 1 by y into ddx of what? Y, because you are thinking y as x. Half you keep it as it is. Now, in this particular case, I can use log x formula if I think x minus 3 as x. So, let us think it as x. So, ddx of log x 1 by 1 by x minus 3 into ddx of what is there? X minus 3. Same way, here also think it as x. 1 by this one, ddx of this expression. Here also, ddx of this expression, think it as x. ddx of what? Log x formula. This is 1 by this one into ddx of this expression. Hope you understand this step. Functions of function, that is chain rule is very important. Okay. So here it is dy dx. I will just bring this y to the right side by 2. And let us do the simplification of this step. 1 by x minus 3, ddx of x is 1, ddx of constant is 0. So it is 1 minus 0. 1 by x square plus 4, ddx of x square is twice x, ddx of constant is 0. So on twice x I have written here. Minus 1 by 3x square plus 4x minus plus 5 into ddx of this expression. 3 is constant, ddx of x square is twice x, 3 to the 6x. 4 is constant, come out, ddx of x is 1 and ddx of constant is 0. So ddx of this expression is this much. Now substitute your y. I have written half, what is y? Under root, this one is not it. This expression, given expression is considered it as y. So put the value of y, under root x minus 3 x square plus 4 by 3x square plus 4x plus 5 into 1 by x minus 3 2x by x square plus 4 6x plus 4 by 3x square plus 4x plus 5. Okay, here this solution is completed. Now I had given one more example here. One type of question I had done. Second type of question. So here you see this is a power. Differentiate x to the power sine x with respect to x. X is greater than 0 and power is a variable. So take log on both sides. And before that, name it as y. So y is equal to x to the power sine x. Take log on both sides. So log of y is equal to log of x to the power sine x. Use the definition of, property of logarithm. Power you write down as a product. That is log of y is equal to sine x into log x. On the right, after this simplification, take ddx on both sides. ddx of log y equal to ddx of this expression. Okay, with respect to x, you have to take derivative. That's why I have to written here ddx. Now, log y can be differentiated if you think it as x. So, log of y is 1 by y into dy dx because you are thinking y as x. It is not actually x. Similarly, here, it is a product of function. It's not it. It's a function of x. It's a function of x. So, you have to use here product rule. That is u ddx of v plus v ddx of u. That is sin x ddx of log x plus log x ddx of sin x. So, it will be dy dx equal to into y sine of this expression. Sin x ddx of log x is 1 by x. Log x ddx of sin x is cos x. Now, I bring this to the right side. X to the power sin x by x minus log of cos x. And this is your answer. Now, I am going to start exercise 5.5. Your question is, differentiate the functions given with respect to x. Question number 1 is cos x, cos twice x, cos thrice x. If you notice the question properly, you see this is a function which is given as a product of three functions. So, if you want, you can use here product rule, product of three functions rule, that is ddx of u into v into w. That rule can be applied. Or the logarithmic differentiation can also be used. I proceed the question by using logarithmic differentiation. That's why I named the function as y. So y is equal to cos x, cos twice x, cos thrice x. Okay. Now I want to convert this product into sum. That's why I'm taking log on both sides. Log of y equal to log of cos x into cos twice x into cos thrice x. And you know, log of mn, that is the sum, product, can be written as log of m plus log of n. So, this can be written as log of the first expression, log of the second factor plus log of the third factor. Okay. So, now this is simplification step is done. After doing the simplification, you have to take derivative on both sides. That is ddx of log y is equal to ddx of the whole expression. Okay. Now you see here, if you think y as x, it converts to log x form. That means chain rule can be used. So I think it as y, and ddx of log x formula is 1 by x. So it will become 1 by y into ddx of y. And here you see this is the sum of the functions, 3 functions. So you can use sum rule. That is ddx of the first expression plus ddx of log of cos twice x plus ddx of log of cos thrice x. Okay. And after this, what I am going to do? This one, you just keep it as it is. As you know, y is considered by u. So you have to replace it. That's why I bring y to the right side. And what is ddx of cos x? Think cos as x and ddx of log x formula can be used. ddx of log x is 1 by x, so it will be 1 by cos x. And you are thinking cos x as x, that's why take derivative of cos x. Similar way, plus is there. You think cos of twice x as x now, and ddx of log x formula is 1 by cos twice x into ddx of cos twice x. Same way, ddx of log of cos thrice x is 1 by cos thrice x into ddx of cos thrice x. Okay. Then dy dx equal to, I have substituted the value of y here. Y is cos x, cos twice x, cos thrice x. You can see here. This is your y. Right? So after substitution, here I just do the simplification. Again, some derivative you have to do. So 1 by cos x, keep it as it is. What is the derivative of cos x? It's minus sin x. Plus 1 by cos twice x, keep it as it is. What is the derivative of cos of 2x? That means cos of mx formula can be used. Or you think twice s as x, again take derivative. Instead of that, I am using here direct formula of cos of mx, which is cos of mx is minus sin of m minus sin of mx. So minus 2 sin of twice x. Same way here also, plus 1 by 3 cos x. M is 3 here, so minus 3 into sin of thrice x. Then what is dy dx? Dy dx equal to cos x, cos twice x, cos thrice x. I'll just keep it all this as it is. Minus sin x by cos x. Sin by cos will give you 10, so minus 10x. This is again plus minus minus. 2 is constant. So I'm writing 2. Sin twice x by cos twice x is 10 twice x. Similar way here also it is minus 3. Sin thrice x by cos thrice x is what? 10 thrice x. And this is your answer. Right? Hope you understand it. After this, I just proceed to question number 2 from your exercise 5.5. Your question is under root x minus 1, x minus 2, x minus 3 by x minus 3 into x minus 4 into x minus 5. So it's a product of a large number, is not it? That's why I'm going to name it as y, and I'll go to take log on both sides. Or here, if you think, yes, we can use here root x formula. But after using root x, you have to take derivative of root x. What is your x? This expression. There you have to use product rule, division rule. Again, inside division rule, you have to use product rule. So the question will be very lengthy. That's why if I take log on both sides, the question becomes simple. So log of y is equal to log of this expression. X minus 1 into x minus 2, whole thing divided by x minus 3 into x minus 4 into x minus 5. And root over means what? The power is half. And in logarithm, we know the power can be written as a product. So in the next step, I am writing the product, this expression as product. Log of y is equal to half into log of the numerator minus log of the denominator, that is log of m by n formula. Okay, division can be written as a difference. Log of the numerator minus log of the denominator. Again in the numerator they are product. So product can be written as sum. So that again I will go to do some more simplification step. Log of y is equal to half log of x minus 1 plus log of x minus 2 minus, again this is the log of this plus log of this plus log of this. And before that we have negative sign. So it becomes minus log of x minus 3 minus log of x minus 4 minus log of x minus 5. Okay. And then I'll take log on both ddx. This simplification step is done. So I will take now differentiation. So ddx of log y equal to half as a constant. So I just keep it outside the derivative. ddx of log of x minus 1 plus is there, ddx of log of x minus 2, minus is there, minus ddx of log of x minus 3, again minus ddx of log of x minus 4, again minus ddx of log of x minus 5. Okay, and then this is again I have used as earlier, the log of y is equal to what? 1 by y dy dx. Have to keep it as it is. Hope you understand it now, that log of x minus 1 is what? 1 by x minus 1 into ddx of x minus 1. Similarly, ddx of log of x minus 2, think of x minus 2 as x. 1 by x minus 2 into ddx of x minus 2. Same proceed the rest also. It is 1 by x minus 3 into ddx of x minus 3. This is 1 by minus 1 by x minus 4 into ddx of x minus 4. Minus 1 by x minus 5 into ddx of x minus 5. After this, some ddx again we have to do. So let us proceed further. And I just, at the same time, I just bring this y to the right side also. Dy dx equal to y by 2 into 1 by x minus 1. What is the derivative of x minus 1? ddx of x is 1, ddx of 1 is constant, it is 0. So it will be 1. Similarly, here also ddx of x is 1 and ddx of constant is 0. So 1 by x minus 2 into 1. Likewise, the rest. 1 by x minus 3 into 1, 1 by x minus 1, x minus 4 into 1, 1 by x minus 5 into 1. Then put the value, that is dy dx equal to half. Y value is equal to what? What is the value of y? Under root of this expression. So put the value, that is equal to here, and 1 by x minus 1 plus 1 by x minus 2 minus x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. And this is your answer. Hope you understand the method. After this, let us proceed to question number 3. Okay. So your question number 3 is log of x to the power cos x. This is the power is a variable. So obviously this question can be done by using logarithmic differentiation only. Because there is no, except e to the power x, there is no other formula having the power as x variable. So I just name it as y. Y is equal to log x to the power cos x. Then do the simplification. Log of y is equal to what? Log of this expression. Then log of y is equal to product will come as a, power will come as a product. So this is cos x into log of log x. Then take ddx on both sides. ddx of log y equal to ddx of cos x into log of log x. Okay. After this, ddx of log y is equal to what? 1 by y dy dx. Here I have to use u into v rule because this is a function of x and it is another function of x. So cos x into ddx of the second expression plus second expression, that is log of log x into ddx of cos x. After this y as you bring to the right side, dy dx will be left on the right, on the left side only dy dx will be left. So y dy dx equal to y into cos x. What is log of log x? Think log x as x, it becomes log of 1 by x. 1 by x form into log of log x. Log of log x and ddx of cos x is minus sin x. Dy dx equal to what is y you substitute? Log x to the power sin cos x. Cos x by log x and ddx of log x is 1 by x. Plus minus is minus sin x into log of log x. So this is the answer of question number 3. Now I'll proceed to question number 4. Your question number 4 is x to the power x minus 2 to the power sin x. This is your question. Again the power is a variable, so I have to name it as y. Y is equal to x to the power x, 2 to the power sin x. Now you see here I cannot take log directly because there is no rule for log of m minus n, right? So I'll not take log on both sides. This is a very important step. This type of questions are set in exam also. So y is equal to, you will just name it as u and this as v. What is u and v? U means x to the power x and v means 2 to the power sin x. After this, both sides I'll take derivative. ddx of y equal to ddx of u minus v, where dy dx equal to du dx minus dv dx. I just mark it as y, 1. And now I'm going to take derivative of this one and this one. Du dx and dv dx, right? So I have written here u is equal to x to the power x. Take log on both sides. Log of u is equal to log of x to the power x. That is log of u is equal to x into log of x. Do the simplification step now. So here log of u, log of ddx of log of u is equal to ddx of x log x. Is not it? So log of u, you can take derivative if I think u as x, which will give you 1 by u du dx. Here it is a product of two functions. So use product rule. That is equal to u ddx of v, that is first function derivative of log x plus log x derivative of x. Simplification step, du dx equal to u just bring to the right side. X ddx of log x is 1 by x, log x ddx of x is 1. Okay, now put the value of x. du dx equal to x to the power x. U means x to the power x. X cancel out 1, and this is equal to what? Log of 1. Log of x. 1 product gives you log of x only. Then after this I go to v. V is equal to 2 to the power sine x. You can use here a to the power x formula, but I have done this directly by taking logarithm. So log of v is equal to log of 2 to the power sine x. Log of v is equal to sine x will come as a product, sine x into log of 2. Take derivative on both sides, ddx of log of v is equal to ddx of sine x into log of 2. ddx of log of v, we think as a x, and 1 by v dv dx. Log 2 is constant, come out, ddx of sine x is cos x. So what is dv dx? V you bring to the right side, log 2 into cos of 2x. Substitute the value of v, dv dx equal to 2 to the power sine x, log of 2 cos of x. So you see, I have just find out the value of du dx and here dv dx. And in question number 1, relation number 1, as I given here, just a minute, I'll show you. Here, in 1, I have marked dy dx equal to du dx minus dv dx. So let us substitute here. Then it will give you, substitution give you dy dx equal to this is, put the value of du dx, which is x to the power x 1 plus log x minus 2 to the power sine x into log of 2 into cos x. And this is your answer of question number 4. One more question let us do now. Here, this is x plus 3 whole square, x plus 4 whole cube, x plus 5 whole to the power 5. You see, it is again a product of a large number. But since the powers are constant, you may use here u into UVW rule, product rule. But I am doing it by using logarithmic differentiation. So I have named it as y. Y is equal to x plus 3 whole square into x plus 4 whole square into x plus 5 whole square. Then take log on both sides, log of this whole expression. Then log of product will convert to sum, that is log of x plus 3 plus log of x plus 4 whole cube plus log of x plus 5 whole to the power 4. After this, the product you write as a power you write as a product, that is log of y equal to 2 log of x plus 3, 3 log of x plus 4, 4 log of x plus 5. Then take ddx, simplification is done, take ddx on both sides. ddx of log y equal to ddx of this whole expression. Log y derivative can be done 1 by y dy dx, and ddx you bring right with all the expression, ddx of this one plus ddx of this one plus ddx of this. ddx of this one will give you 2 is a constant, it will come out. ddx of log x is 1 by x into ddx of x plus 3. Plus 3 is a constant, come out, ddx of x plus 4 is 1 by x plus 4 into ddx of x plus 4. Similarly, here also 4 is a constant, so it will come out, ddx of x plus 5 is 1 by x plus 5 into ddx of x plus 5. Then you write down what is your y, dy dx is y just bring to the right side. This is 2 by x plus 3 into dx of this expression is 1. 3 by x plus 4, dx of this expression is 1 plus dx of x plus dx of 4, that is 1 plus 0, that is 1. And here it is 4 by 5, x plus 5 into 1. Then here substituting the value of y, we get x plus 3 whole square, x plus 4 whole cube, x plus 5 whole to the power 5 into what? The last expression is 2 by x plus 3 by x plus 4 and 4 by x plus 5. So with this I stop here the solutions. Remaining questions I'll do in my next video. Thank you.